Wait, hold on, just the first step.
First step.
Obtain 1 vial containing a sample of iodine crystals and 1 vial containing zinc granules from your laboratory instructor.
All right. First step. So iodine's in the hoods. There's probably a reason for that. And then the zinc's on the other side. Okay. What's next?
Determine the mass of.
No, we're moving
No?
one person. You only have to answer once.
Oh, okay, I don't count.
You can answer.
No, but I
Oh,
just
I
tried
just,
to.
I just did that one.
Oh,
I just-
sorry. You were talking and her lips were moving. I'm sorry.
What? Okay, determine the mass of a clean, dry, 125 milliliter Erlenmeyer flask to the nearest milligram.
Not you.
You.
So 125 mil Erlenmeyer, right?
Uh-huh. To the nearest milligram.
0. It says milligram?
Nearest milligram. Says it.
Okay. But we're gonna actually go to what? Yeah. All right, Erlenmeyer. Okay, so there's a caveat on this one already, right? Do we have to have a plug? Is there a plug involved?
It doesn't say anything about a plug.
Anyone?
Not
Farther on? Okay. Go ahead. So the caveat is be careful if this weighs more than like 90. Don't use a different flask. Right? Okay. Next.
Measure out a 1.5 gram sample of clean mesh granular zinc from a weighing bottle using the technique of weighing by difference. Record the mass of weighing bottle, cover and zinc to the nearest 0.001 gram. Pour out a few granules of zinc into the pre-weighed Erlenmeyer flask and reweigh the weighing bottle. Put the cover on. Continue with.
Whoa. This is all one step?
Yeah.
No, that's more than one step
Oh.
to me. So
Yeah,
let's break it down. Let's break it down. What's the first thing?
It's a measure out 1.5 grams sample of 20 mesh granular zinc.
Okay, so we're gonna use our entire vial of zinc. Right, we're only doing this once, right? Or how many trials do we have?
At part 9, you repeat this 2 times.
Oh, so we have 3 trials. So that means we don't use the entire thing of zinc then. So let's be careful. So let's use, so that means there may be enough for 3 trials. Use 1.5 grams of zinc. Okay. Then what's next step? So we'll just call this 3A then. What's 3B? Well, go ahead, Adrian, you stay with the whole thing.
Record the mass of the weighing bottle.
Right.
Cover on. And zinc to the nearest 0.00.
Right, so we're okay, so are we doing weight by difference? What are we doing? So we're gonna weigh the bottle and then we're gonna dump out about 1.5 grams. Is that what we're doing?
Correct.
Let's convert this into to like something we understand. So I'm gonna take this bottle, I'm gonna weigh it, and then what's my next step? I'm gonna pour out, what, 1.5 grams, is that? Where do I pour that? I mean, I just weighed it, and now I have it, and it wants me to pour out 1.5 grams, what do I pour it into?
Into the Erlenmeyer flask.
Oh, weighed Erlenmeyer?
The pre-weighed.
Well, yeah, we weighed it right here. Right? That's the pre-weigh. All right, and then use the, so we're gonna dump the whole, I don't understand, try to, like, I don't have the instructions, you have the instructions, you gotta help me figure out what I'm gonna do. Do you understand how I'm doing this? Like, I don't know anything, and which is true. And then, so it's real easy, you just have to tell me what to do, and then I put it on the board, and then we all know what to do, because if I know how to do it, then obviously you guys know how to do it. So I've got this flask, and I got that, oh, I've got an Erlenmeyer. All right. I'm gonna steal yours for a second. All right. And now this is weighed, I'm gonna pour this in here, all of it, I guess, I don't know, 1.5 grams, might as well see. Huh?
It just says pour out a few, like what's a few?
Remember, we always carry our scale. When we're reporting weights, 22.904, I write that down without leaving the scale. If I have to leave the scale, I don't write it down. I go get my piece of paper, my lab book, whatever, I should have it with me. Here we go. And I write it down. This lab procedure. The reason I'm doing this is so that you guys get to see it done correctly. All right. And then I take that off. I don't know. I'm guessing it's 1.5. Uh-oh, I think I'm way wrong. Nope. 20.8654 grams. Let's see. All right. Now I can leave the scale. I didn't weigh this, but we already weighed it. Whatever. All right. So now I have the amount of zinc. So what I've done is I've transferred my amount of zinc, and I have that amount from my two weights. So, wow, empty into flask. All right, what's next? Adrian?
It says to continue the procedure until the specified sink has been transferred to the Erlenmeyer flask.
Okay, what?
Yeah.
Okay, and now, is that the end of that?
Uh-huh.
Okay.
Measure the mass of the iodine in its vial with cap.
Weigh iodine. Okay? So I would do that, but I don't understand what's going on over here. All right, so I'm gonna weigh this. It said here. Okay, good. Now what?
Remove the cap and pour the entire contents into the Erlenmeyer flask.
Ooh. I'm doing that. But I'm not doing it without gloves on. Why? Because the iodine's caustic.
That would be small.
You can work back my personality. All right. And the thing is after you watch me do it, there shouldn't be a lot of question about what we're gonna do. Well, if I did this, why would I do this without weighing it? What would I know if I thought I could do this without weighing it?
Nothing.
Okay, something to think about. All right, so weigh iodine. I put it in the bottle. Now what?
Make sure that none of the iodine is clinging to the outside of the vial. Remeasure the mass of the vial with cap to determine how much iodine has been transferred.
Right? Weigh iodine transfer to Erlenmeyer. So I'm not only taking the instructions and trying to decipher them, which I should do before I get here. I'm working through what I'm doing while I'm doing it. I'm not just taking the words and putting them on from one place to another. I'm really like, what am I supposed to do with this? What am I supposed to, look, I got two of them, how did that happen? Anyway, so I've got it in the file, I've reweighed it, now I know how much iodine and how much zinc I have in there, right? Because I've weighed both of those. So what do we do, what do we do with those weights? Those masses? What do you think we're gonna do? Convert to grams. No, convert to moles. We're already in grams. All right. Okay, what's the next step?
The mass of iodine transferred should be in the range from 2.00.
I don't care. All right, what's next? Because it said put the whole thing in there, right? But what the follow-up is, you should know about how much that is so that you know your accuracy. What's the next step? Was that the same step? Are we still on the same step? We don't.
Add 35 milliliters of ethanol to
35 mils of ethanol. And how am I supposed to do that?
Since we cover the flask with a piece of aluminum foil, side-sided,
This is before or after? I'm going to add ethanol before or after? Where's the ethanol? Oh, there's the ethanol. It's right here. And I'm supposed to add how much? 35? So I need the big. This one. Of course, you don't do this, but I do. What is ethanol, by the way? Alcohol. Yeah, it's just, you can't drink it though, it's 95%. So there's 35. Okay, that's this color, that's the iodine crystals being dissolved. That was terrible. It spilled all over the place. It's a felony. Don't do it. All right. What's the next step? Now I can't hear you. See how hard it is to be a chemist? That's terrible. All right, what now?
place the flask on a hot plate.
I thought we were supposed to do it in the hood.
Cover it with foil and put it on the hot plate.
That's what it says, right? But we have too many people. Does it say to do it in the hood?
I don't remember it saying.
No, I didn't say that. You just said loosely cover the flask with foil.
Oh, so to avoid the fumes, we're going to cover it with foil. All right, so that's why the foil's important.
It's one way.
Ooh, don't remember that. 35 mils of ethanol into flask, cover with aluminum. All right, and then boil. And then we got to be going to then heat transfer to heating whatever. What is the thing called? Hot plate. Hot plate. Heat for how long?
For about 20 minutes on low heat.
Low heat. Approximately, this little tilde, right? We use tilde for approximately. Low heat. 20 minutes. All right, well, you're not waiting while I do that. What comes next?
I'll write down any on the
Yeah, oh, so the whole time, right? Why do you think I said, oh, look at this color change, right? Oh, look at this color change.
Low heat and then-
That's not the same color it was. Right? So one thing, we don't spill the ethanol. Second thing is, we keep track of everything as it's happening, right? We watch for, you write down, okay, solid crystals were at, zinc crystals and iodine crystals were at the bottom of the flask. They did not appear to have any reactivity. Poured ethanol over the top, immediately iodine crystals dissolved. I saw an orangish yellow solution. Minutes later, very dark. There's some red tinge to it, right? I haven't even started doing anything yet, but I'm watching it the whole time and describing what's happening. That's the childlike wonder, the fascination. Why is it red? I thought it was brown and yellow. So something's going on, right? We just don't know what it is. And we don't need to, but we need to describe what we see. That's the part. That's the part where, like, when somebody goes back and looks at your work and they go, oh, look at that, right there, it turned orange, something happened. I wonder what happened right there, and then they can hone in on it. But if you don't write it down, they don't even know anybody else has ever observed it. And then they might think it'd be a fluke. But if 60 people have done this, and all 60 of them say, after about 2 minutes, I saw this change. Now all of a sudden you have a a pattern, a transition. You have a chain of custody, so to speak, where you know each thing that happened, and the more people that describe it, the more honed in we can get on that experience. All right, so that's one of the reasons why we do repetitive science. Okay, what's our next step?
Continue heating the flask until the solution is clear.
Oh, that's our giveaway. Heat till clear? Is that what you just said? Yeah. So we know what we're looking for. We're heating about 20 minutes or until it becomes clear. Well, that's going to be pretty easy to note, right? This is not clear. Really, that's not clear. So low heat, 20 minutes till clear. Then what?
Well, the reaction is progressing to determine the mass of a clean, dry, 150 milliliter beaker.
More weighing. So much weighing. Weigh 150 mil beaker. Okay. So you can do this while heating. Since you're going to be working in groups, right? All right.
When the reaction is complete, take the liquid from the flask into the beaker, leave any unreacted solid behind.
Okay. After completion, transfer the beaker. Well, let's put decant, because that's what decant means. Pour off the liquid. Right, we're just cooking today. Oh, wait, pour off the cooking? No, pour off the liquid. Boy, my ADHD is so good today. It's awesome. All right, pour off the liquid. So when we get done, we know when we're done because it's clear. We can see the solids at the bottom. We pour that off, and now we're collecting that in a pre-weighed beaker. Are we doing it while it's hot? Are we doing it while it's hot? Doesn't say anything about that. What's the next step?
Pour 5 milliliters of ethanol on the unreacted solid to wash away the product away from the sink.
Okay, so I guess, oh, we're doing it low heat, so I guess we're all right anyway. Then what? So repeat that. It was too much for me.
Pour 5 milliliters of ethanol on the unreacted solid to wash away the product away from the remaining sink.
Okay. So we're going to rinse with ethanol. 5 mil ethanol rinse. And collect in beaker. And decant again. All right. Anything else?
And then gently swirl for about 15 seconds. And then we're going to decant the washed ethanol into the product beaker.
5 mil ethanol rinse. And how long? 15 seconds?
Yeah.
Okay. Thank you. Next step? Or are we still on?
It says to repeat this process with 2 additional 5.
Ah, thank you. Repeat twice. No, repeat 2 more times. So, repeat. So 15 mils altogether. All right. And all we're doing there is making sure we rinse everything off the surface of the unreacted metal. All right. Which is going to help us in determining how good our yield is.
Put Erlenmeyer flask on a hot plate to dry.
Heat Erlenmeyer. So this is the one with Erlenmeyer with product?
Yeah.
Or is it a beaker?
No, the flask.
Oh, heat the solid.
Yeah, so then hot plate, you got to dry, then let cool, and determine the mass of the unreacted solid.
Left over, oh, let's call it excess. Okay. All right. Are we almost done? We've got to be almost done.
Finish a beaker containing the product dissolved in ethanol and water.
Okay. So, what do we, heat solution now, right? For how long?
Yeah, we've already solution to evaporate the solvent.
All right. So, heat solution gently to evaporate solvent. Can you help Priscilla out?
When the last traces of the solvent disappear, allow the beaker to remain on the hot plate for an additional 2 minutes.
Okay. So we've already heated the solid, right? We don't throw either part away. We heat the solid till it's dry. We weigh that, put it aside. Then we take the solution that we've rinsed with 3 portions of ethanol, right? And now we're going to heat that to dryness plus 2 minutes. Gently heat past dry 2 minutes. Okay?
Allow the beaker containing the dry product to cool to room temp while covered with a watch glass or large inverted beaker.
Okay. So, cool and cover. Does it give it a time?
No.
Okay. Next step. Please tell us we're almost done.
Should be the last one. It says to dissolve your product in H2O and pour it into the waste container.
Whoa, whoa, whoa. No, there's something's missing. We didn't weigh anything. We just lost our entire experiment.
Are we still on step 12?
Maybe. I don't know. I don't know. All I know is it's a little early to be throwing things away.
So we're still on step 12. I thought we were going on to the next one. Yeah, so
Yeah.
we're going to determine the mass of the beaker and sample.
Okay. Cool, cover. Does it say when? Like, just when it's cool, I guess.
When completely cool.
When completely cool. Cool and cover, when cool, weigh. Okay. And now, right, because now we have the weight, this is the mass of product right here. That's a big step right there. Okay, and then dissolve in minimal H2O. Oh. Ooh, look at that. H2O. Take a picture. The guy I teach with at Santa Barbara, he just writes like unbelievably well. Horrible, these people with education degrees. All right, so, not that he has one, I'm just saying he writes very well. All right. Okay, so, doesn't sound like it's gonna take that long. Like, I would almost be done heating by now, right? All right, so any questions on what we're doing? Oh, what are we making? There you go. So we're taking zinc metal, right? Plus I2, because iodine's halogen and it comes in that form. and that's a liquid, I guess. Or is it a solid? And then we're making zinc iodide, solid, right? Zinc iodide solid. And then what we do as chemists is we write ethanol, like usually right above the arrow or below the arrow. That tells us what the solvent was. So that's our equation. Only it doesn't balance, right? So one of the reasons why I knew I didn't have to measure the iodide is because I knew it was going to be the limiting reagent. But I do have to measure that then, huh? Oh, so that would have been a bad assumption. So make sure you measure everything. All right? Don't be like me. All right. So, any questions? Okay, I'll walk around and you can get started, and hopefully you have all the stuff done you're supposed to. I appreciate it.